In this video, I am going to show you how to solve the first FlareOn challenge from FireEye using the Binsec platform and especially the dynamic symbolic execution engine. Here is the control flow graph of the program, where various API calls are being made up until this one, which is reading a key on the keyboard. The key is stored into input buffer, and we are going to iterate through each characters, XORing every character and comparing them to the content of data str. If the comparison is wrong, we are reaching the failure block, and after 25 iterations, if every characters are right, we are reaching the success block. So we are going to execute it symbolically. One point of the execution is that we'll have to provide an initial state for data str, because in symbolic execution, because the memory is symbolic by default, the solver will be able to give an evaluation for the content of this address, which is normally read-only. So we'll have to constrain the memory of these addresses. So we are going to generate a trace using a configuration file. The configuration file is this one. So we provide the start address, the stop address, and various calls that we don't want to trace. These calls are these calls. So we are not going into these calls because it would imply an overhead of instructions. And we do provide this initial state, which is the value, the byte value of the data str content. So we do generate a trace using the pin tool. Here is the output file, which is a protobuf file. We provide the configuration file, and let's start to trace. So here it asks for the password, so we enter whatever we want. So we are a failure. We can basically print the trace, the content of the trace. So here there is the GNZ in which we are interested, and as you can see, there is all the concrete information that have been gathered during the execution. So the analysis itself is this one. So this is a class in OCaml that inherits from trace analysis. So we declared some various constants, and we used the basic callback functions, which is pre-execution, executed once at the beginning of an analysis. Visit before, which is executed for every assembly instructions. Visit DBA before, which is executed for every DBA instructions. DBA is the intermediate representations used internally. And as you can see, the code is rather simple. So if we are on the GNZ address, and if the DBA instructions is the comparisons of the ZDEF flag, we are going to build the predicate of the conditions, build the negations of this predicate, build the formula with the whole path predicate, trying to solve this formula, and the output is the result and a model if the formula is satisfiable. If the result is satisfiable, what we are going to do is basically get into the initial memory the value of the right character and print it on the output. So here is the command line. We are using the configuration file. We specify that it's std call, so that we'll be able to stop the call we had skipped. This is the trace, and here is the execution. We have when reaching the GNZ instructions, we we get into that matching condition, and we have successfully computed the red character, which is B. So from now you have two options. Either you create a new input and that will patch the value into the buffer during the execution, which is possible, but for that you will have to create a new trace for every character. Or we can use another features of Binsec, which is dynamically interacting between a dynamic interaction between the Binsec and Binsec by using message API. So here is the callback for, so we get the input message received, and we can do whatever. This is the message that are received from Binsec. So if we receive the breakpoint reached message, what we are going to do is reply to Binsec to patch the ZF flag and to resume the executions. But for that, we will have to set a breakpoint on this instruction, and we can do it by specifying it into the configuration file. So we are going to break on that address. So let's start again to trace it. This time we are going to use another command line. So we are specifying an host and port on which to listen the trace, and we will do the same on the okay, here it is. We specify that we are doing it as a server on a given port with the given configuration file which has the breakpoint. So we are starting back the tracing. Okay, we type whatever into the buffer, and here it is. We have forced to patch the ZF and to resume, and by doing so we have been able to loop through every characters, and as you can see we have found every one of them, and at the end we've reached the success block, and at this moment we print the key we have gathered at every GNZ instructions. So here it is. The demo was pretty short to present all the APIs, but feel free to try the tool, see the documentation. All the links are provided in the description of this video, and don't hesitate asking any questions by mail or contacting us directly. Thank you.